So hello and welcome to today's class. Today we'll discuss about the chapter Electrostatics. So what is static? When a body is at rest, we call it static. So electrostatic means when charges are at rest, charges at rest, then we call it electrostatics. Okay? So we know basically matter is composed of elementary particles called as electrons, protons, neutrons. Neutrons are chargeless particles, but electrons are negatively charged particles and protons are positively charged particles. And each elementary particles contains some mass. So as we have read in the 11th class, when two bodies are separated by a distance r and having some mass, when two bodies possessing some mass m1, m2, okay, when they are separated by a distance r, then they are attracted by a gravitational force g m1 m2 by r square. So what is g? That is the gravitational constant. M is the mass of the first particle, m2 is the mass of the second particle, and r is the distance between them. So if we calculate the gravitational force of attraction between two electrons, that is two negatively charged particle electrons separated by a distance 1 centimeter, and you put this formula and mass of the electron and r you convert to meter, that is the SI unit, you find 5.5 into 10 to the power minus 67 Newton is the gravitational force of attraction between two electrons separated by a distance 1 centimeter. However, it was found that when two electrons are separated by a distance 1 centimeter, they are not attracting each other, but they are found to repel one another with a force 2.3 into 10 to the power minus 24 Newton. Okay, so this force is very larger than what we calculated the gravitational force of attraction between two electrons. So how do we find this force between force of repulsion between two lightly charged particles? So Coulomb was the scientist who gave this law. This is called Coulomb's law. Okay, so here is one particle called Q1, positively charged particle called Q1, and here is one particle, positively charged particle called Q2, separated by a distance r. If Q1 and Q2 are two positively charged particles separated by a distance r, then the magnitude of force, of repulsion between them is 1 by 4 pi epsilon 0 q1 q2 by r square. So now we are just talking about the magnitude. Okay, so what is epsilon 0? Epsilon 0 is the permittivity of free space, permittivity of free space. So what is the value of epsilon 0? Epsilon 0 is 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square. Please be careful with the units always, because these are the quantities which usually come in the examinations, and that may confuse you. Okay, so the magnitude of force is 1 by 4 pi epsilon 0 q1 mod q2 mod modulus by r square. Okay, so as we know, 1 by 4 pi epsilon 0 is a constant. constant of proportionality. Okay, so 4 is a constant, pi is a constant, and epsilon 0 also do possess a constant value, and this whole quantity is a constant. Okay, so as we know, force is a vector quantity. It has some directional property. Okay, it has some dimensions. So before when we are talking about the electric force, when we are talking about the electrostatic force of attraction or repulsion between two charged elements, so in that case we have to take some sign conventions. Suppose here is a charged particle, positively charged particle q1, and here is a charged particle q2. Okay, so F12, what is F12? It is the force exerted by 2 on 1. So you have to be very cautious with the sign conventions. So what is F12? Force on 1 by 2. Similarly, what is F21? Force on 2 by the particle Q1. So in this case, when the what should be the direction of F12 when what is the direction of the force by Q2 on Q1? So that will be towards the left side. And what is the direction of the force Q1 on Q2? That will be on the right side. So there are some rules of the sign conventions. Okay, the direction of electrostatic force by a positively charged particle is always away from the particle. Suppose there is a positively charged particle q1. Okay, so suppose q1 is exerting a force on the particle q2. That means the force will be towards this direction. Okay, away from the positively charged particle. Similarly, uh, the direction of electrostatic force by a negatively charged particle is towards it. Okay, so suppose q2 is a negatively charged particle. So what is the direction of electrostatic force exerted by 2 on 1? So that will be F12. Okay, that is the force exerted by the charged particle q2 on q1, that is towards the negatively charged particle, that is again towards this side, right hand side. Okay, so there are some shortcuts which we need to use while solving some problems. Frequently we'll come across this quantity while solving problems on electrostatics. So the value of 1 by 4 pi epsilon 0 is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, so what is the value of E by m? That is the charge of electron. That is the value. What is the value of the charge of an electron divided by mass of an electron? The ratio of charge of an electron by mass of an electron is 1.76 into 10 to the power 11 Coulomb per kg. Okay. So these are some of the shortcuts which you need to note down so that it will be beneficial to you while solving problems on electrostatics. Okay, so in this video we can talk the whole chapter. So today we'll basically restrict our talk to the Coulomb's law, and in the next class so today we'll solve some problems on Coulomb's law, and in the next class we are going to solve some more problems on Coulomb's law. Okay, so what is quantization of charge? Actually, when a system, if it possesses N1 protons and N2 electrons, and as I said, protons are positively charged and electrons are negatively charged, where N1 and N2 are integers. Suppose a body contains 2 protons and 3 electrons. So what is the net charge contained in the whole system. So that is N1 in and the charge of electron plus N2 charge of N1 charge of proton plus N2 charge of electron. So basically, in that case, we can say the charge is quantized, where n stands for integer, that is equal to plus or minus 1, plus or minus 2. You can have whole lot of quantities. So, what is the physical significance of the quantization of charge? Basically, you can have a system of 60 electronic charge. Okay, so you can have a system minus 51 E, but you cannot have a system with 3.57 E. So electron is the basic, that means the fundamental quantity, is one of the fundamental quantity, and depending upon the charge of the electron, we can actually define the charge of any body. So that is in the multiples of electron. Okay. So basically some theoretical questions also come in your objective type examinations. So what was the experiment that was conducted to prove that charge is quantized? That means any body which suppose charge of a body is multiples of electronic charge. Okay. So it was the Millikan oil drop experiment which was responsible for proving the quantization of charge. And this Millikan scientist, he got Nobel Prize in Physics in the year 1923. So there may be four options. Okay, so which of these experiments proved the quantization of charge? So the four options would be Millikan oil drop experiment, photoelectric effect, okay, Compton effect, and none of these, or all of these. Okay, so in that case you can answer such type of questions. So let us come to one easy problem. Okay, on the topic Coulomb's law. So this figure actually, figure 1 shows two particles fixed in a place. A particle of charge q1 is equal to 8q. q1 is equal to 8q at the origin, and the particle of charge q2 equal to 2q. q2 is equal to 2q at x is equal to L. At what point can a proton be placed so that it is in equilibrium? Okay, so basically q1 charge is at origin. Okay, suppose this is the xy direction as I have drawn here, and q1 charge is at origin, that is x is equal to 0, and q2 is at x is equal to L. So what is the distance between q1 and q2? That is L. Here instead of r, we are going to use L here. Okay, and the value of charge q1 is 1.6 into 10 to the power minus 19 coulomb, and the value of charge q2 is equal to 3.2 into 10 to the power minus 19 coulomb. Regarding q3, I will say later. I will give you one problem. I will extend this problem and ask you to solve that question. Okay, so let us consider the proton to be placed between the charge q1 and q2. Let us consider the proton to be placed in between the charge q1 and q2. So considering the directional property, so what should be F31? Let us denote the proton to be charge q3. So what should be the direction of the force F31? That is the force exerted on 3 due to the charge q1. So that will be towards the right side, that means away from the particle q1. Again, what should be the force F32? That is the force on the proton q3, or on the particle q3 due to q2. So that will be towards the negatively charged particle, so that will be again towards the right side. So since both the force are in same direction, since both the force are in same direction, so they cannot cancel each other. Okay, so they cannot cancel each other. Now let us assume the proton to be placed towards the left side of the charge q1. Okay, and consider the distance between the charge q3 or the proton and q2 be x, and this we know it is L. Okay, q1 and q2 distance is L as given in the question. So what will be the distance between q1 and proton? That should be x minus L. Okay, so considering the directional property, so what should be F31? Again, the F31 will be away from the particle q1, since q1 is positively charged particle. And what should be the direction of the force F32? So that will be towards the negatively charged particle q2. So in the direction wise, we can say the both forces can cancel each other. However, we have to consider magnitude also. So what is the magnitude of what should be the magnitude of F31? So K Q1 means that is given in the question 8Q, and Q2 is 2Q. So 8Q into charge of the proton, suppose QP, divided by this is the distance, this is a small distance. So this quantity is no doubt a bigger quantity than F32, because denominator here is larger, x is greater than x minus L, and again numerator is also larger. So they cannot cancel each other. So let us now consider the proton to be placed on the right hand side of the charge q2. So again considering the distance x between the charge q1 and the proton, and L we know, and this should be the distance between q2 and qp is x minus L. So on the direction wise, we can say F31, if we consider F31, so that will be away from the particle q1. Okay, and on the direction wise, if we'll see F32, that is the force exerted on the proton q3 by the negatively charged particle q2, that will be towards the negatively charged particle q2. Okay, so the forces cancel each other directionally. So now we can see the magnitude. Oh, so what should be F31? That is K into A. K is the 1 by 4 pi epsilon 0. Okay, so 8Q into QP by x square. X is the larger distance, and F32 is equal to K 2Q into QP by this is the smaller distance. So they may that means a equilibrium point may exist, because the forces can cancel each other, and as well as the magnitude can cancel each other. So we have to solve this problem by considering F31, by considering F3 just a second. Okay, so we have to consider we have to consider the magnitude of F31 and F32, and we have to consider the equilibrium condition, that means F31 equal to F32. So solving this quantity, we can get, on solving we can get x is equal to 2L. That means when the proton is placed at a distance x is equal to 2L from the charge q1, then we can say the proton can be placed in the equilibrium. Proton is in the equilibrium condition, considering these two charge configurations. Okay, so let us solve one more problem. The question is on your screen. There are four charges q1, q2, q3 and q4, and they are in the they form a square of side A equal to 5 centimeter. Okay, that is on your screen. So what is the question? What are the x and y components of the net electrostatic force on particle q3? So before solving this problem, let us discuss one principle that is called principle of superposition of charges. What is this? What is the physical significance actually? Suppose there is a particle, let's say Q2 here, and there is a particle, let's say Q1 here, and the principle of superposition of charges say that is the force exerted on the particle q1 due to particle q2, that is suppose f12 is not affected by the presence of charges in its surroundings. Suppose there is a particle called q3 here, and there is a particle called q4 here, and anywhere in the surrounding, suppose there are n number of charges. So the F12, that is force exerted on 1 due to 2, is not affected by Q3, Q4, Q5 or Qn. Similarly, so for force exerted on 1 due to Q4 is not affected by the charge Q2 or Q3 or Qn. And what is the net? If we talk about the net electrostatic force, that is the total electrostatic force on a specific charge. So in that case, on a specific charge q1, okay, so in that case we have to add the vector sum of the force due to individual charges. That means the force due to q3 on q1, the force due to q2 on q1, the force due to q4 on q1, like that. Okay, so coming to the problem again. So here the question is about the x and y component. What is the net electrostatic force? What is the x and y components of the force on Q3? So basically there are three surrounding charges. So first we'll see the whole net charge is a vector sum of F31, 32 and 34 due to 1, due to 2 and due to 4. So what will be F31? So 1 by 4 pi epsilon 0 minus Q3 Q1 by A square. Why this minus sign is coming? Because the q1 is positively charged particle here. Q1 is positively charged particle, and where the force will be the force exerted by q1 will be away from the particle, so it is in the negative y direction. Okay, it is just like the just in the direction of negative y axis. Hence considering the vector notation, we have to put a minus sign here. Similarly, Q3 and what is the force due to F32? So suppose here is the particle Q3 and here is the particle Q2, and it is on the diagonal of a square. So the distance between the two particles will be two charges will be √2a. Okay, so that can be again divided into x components and y components. So since it is a square, so if we divide the resultant electric force into x and y components, so angle will be 45 degree. So x component will be cos 45 degree I cap, and similarly y component will be sine 45 degree I cap. Okay, j cap. Okay, so again what is the force F34? Here we can just a second, there is some error. Okay, so what is the force F34? So that is Q3 Q4 I cap divided by a square, because Q4 is a negatively charged particle, minus Q4. Okay, so Q4 is a negatively charged particle, so the force exerted by Q4 will be towards Q4, and this is nothing but the positive x direction. So just divide the whole equation into x component and y components. That means just separate the x components part and separate the y components parts as shown in this slide. Okay, so I'm solving the x component parts by putting the value given in the question, that is 100 nanocoulomb. Nanocoulomb is nothing but 1 nanocoulomb is nothing but 1 into 10 to the power minus 9 coulomb. Okay, nano means 10 to the power minus 9. So put those values like 100 coulomb, nano coulomb, 200 nano coulomb, and minus plus whatever it is given in the question, and just convert the centimeter to meter in SI units, and you get 0.17 Newton as the X component, and the Y component you get 0.046 Newton. Okay, so this much for today. So I'll translate some basic points in Odia for the students of Odisha. Those who have problem, some of the important points I will translate in Odia language. Okay, so ଯେମିତି ଆମେ ଦେଖିଲେ जो ग्राविटेशनल फोर्स दीटा इलेक्ट्रॉन भितर जदि आमे कैलकुलेट करिवा जोटा आमे 11th क्लास रे पढ़थिले तो g होची हमरो ग्रेविटेशनल कांस्टेंट तो ताकू मास ऑफ द इलेक्ट्रॉन होची 9.1 into 10 to the power minus 31 kg आमे एई सब वैल्यू पुट करके जदि बाहर करिवा हमरो 10 to the power minus 67 ऑर्डर रे फोर्स आसुची ग्रेविटेशनल फोर्स बिटवीन टू इलेक्ट्रॉन सेपरेटेड बाय 1 सेंटीमीटर सेमती जेतेबेले किंतु देखा गला कोन द जदि दीटा इलेक्ट्रॉन separated by 1 centimeter अछंदी then they are actually repelled by one another माने दी जण परस्पर ठु दूरे जाउचंती काहे कि दी जणकर चार्ज सेम so they repel one another with a force 10 to the power minus 24 newton जोटा कि बहुत greater than this gravitational force so it actually किए बाहर करथिले एटा Coulomb's law द्वारा हमें जो force of repulsion between two charges या force of attraction between two charges हमें calculate कर परिवा so this is basically the formula for the magnitude of electrostatic force एमति कि 1 by 4 pi epsilon 0 q1 mod q2 modulus by r square r जदि distance so हमको गोटे force जेहेतु कि गोटे vector quantity तो हमको force फोर्स रो डायरेक्शनल प्रॉपर्टी भी स्टडी करिया पड़िबो खाली मैग्नीट्यूड नो सो आमे करिया पूर्व किछटा साइन कन्वेंशंस नबा जदि गोटे चार्ज q1 अछि एटी q2 अछि सेपरेटेड बाय डिस्टेंस r so f12 को आमे कोन लिखे कहि परिबा द फोर्स एक्सर्टेड ऑन वन by 2 by the charge 2 माने q1 ऊपरे q2 केते फोर्स पकोछि दैट इज f12 सिमिलरली f21 हमें कौन कर परिबा the force on 2 force exerted on the charge q2 by the particle q1 or the charge q1 तो गोटे पॉजिटिव चार्ज पार्टिकल चार्ज जदि अछि गोटे पॉजिटिव चार्ज ये जेतेबेले फोर्स पकेबो कोनोसी गोटे अन्य चार्ज ऊपरे तेबे जो फोर्स अछि तार डायरेक्शन जस्ट अ सेकंड there is some problem okay so ये जदि कोनोसी ऊपर गोटे फोर्स पकेबो ए चार्ज क्यू चार्ज जदि अन्य कोनोसी चार्ज ऊपर फोर्स पकेबो ताले पॉजिटिवली चार्ज जदि हेतिबो द डायरेक्शन ऑफ फोर्स इज अवे फ्रॉम द पार्टिकल आ एटा जदि माइनस क्यू हेतिबो ताले ये जो फोर्स पकेबो दैट इज टुवर्ड्स इट टुवर्ड्स द चार्ज तो आमे किछटा शॉर्टकट्स भी यूज करथिले एई जो टॉक रे जेमति कि 1 by 4 pi epsilon 0 गोटे कांस्टेंट एटा तमे नबो 9 into 10 to the power 9 आउ चार्ज ऑफ द इलेक्ट्रॉन बाय मास ऑफ द इलेक्ट्रॉन होची आर जो वैल्यू एटा को नोट डाउन करिया पड़िबो सो दीस वैल्यूज विल एक्चुअली कम बेनिफिशियल इन एग्जामिनेशंस सो हमरो जो क्वांटाइजेशन ऑफ चार्ज होची जे हमें गोटे चार्ज गोटे सिस्टम रे 60 इलेक्ट्रॉन 60 e माने चार्ज ऑफ एन इलेक्ट्रॉन रही परिबो या फिर -24 e एमती रही परिबो बट -2.7 e the charge of electron केबे भी रही परिबो नहीं so that should be an integer q equal to n e where e stands for the charge of an electron okay so different problems हमें solve कले जेमति कि डायरेक्शनल प्रॉपर्टी को यूज करके गोटे प्रॉब्लम एटी फर्स्ट प्रॉब्लम में ऑलरेडी सॉल्व करछे एंड आज पई एति कि आगामी क्लास रे मु गोटे नुआ टॉपिक को नहीं कि आसीबी एंड आमे कि जेटा प्रॉब्लम भी सॉल्व करबा Coulomb's law ऊपर. Okay, so thank you and please like and subscribe my channel. Thank you.